Good day. This lesson is all about rocks. Our objectives are explain the rock cycle and give an example of each connecting segments, compare and contrast the characteristics of volcanic and plutonic igneous rocks, enumerate the types of sedimentary rocks, define the terms metamorphism and foliation, describe the geologic products that result from mechanical and chemical weathering. Rock is a solid aggregate of one or more minerals. They are categorized based on how they form. Geologists define three main categories. We have we have igneous rocks, sedimentary rocks, and metamorphic rocks. This picture shows you the three types of rocks: igneous, sedimentary, and metamorphic. They are formed through rock cycle. Rock cycle is a series of processes that create and transform the types of rocks in Earth's crust. So we can see here rocks like igneous transforming into metamorphic, and metamorphic into sedimentary, sedimentary into igneous, and vice versa. There are many processes involved in the rock cycle. Example, the terms in white circles or ellipses, they show the process of transformation from one rock to another rock. Example, all rocks start as part of magma. And when magma solidified, they turned into igneous rocks. Igneous rocks may transform into two types of igneous rocks. There are two types, intrusive and extrusive. If magma crystallize, then igneous rocks are called intrusive. If magma consolidates, then igneous rocks are called extrusive. More specifically, intrusive igneous rocks, they cool down beneath the land. Extrusive rocks, on the other hand, they cool down outside the volcano. So some rocks are uplifted and exposed to environment and atmosphere. Some rocks they weather and transported into nearby bodies of water, and they deposit in this nearby body of water and they become sediments. And sediments lithify. Lithify means compaction and cementation. Through time, these rocks become sedimentary rocks. If these rocks they are transformed through heat and pressure, they become metamorphic rocks. Remember that the rock cycle is not a one-way cycle. It means sedimentary rocks can become metamorphic or can become igneous again. Now just remember, all rocks, when they're melted, they become igneous rocks. If rocks they are formed through compaction and cementation, they become sedimentary rocks. And if rocks are formed through extreme heat and pressure, they become metamorphic rocks. Igneous rocks, these are rocks that crystallize and solidified from hot magma. So in short way of saying, in other words, igneous rocks are volcanic rocks or lava rocks. These are rocks that underwent melt process of melting. They become part of the magma and solidified. One example is called the granite. Granite is one of the most common igneous rocks on land. We've mentioned a while ago that there are two types of igneous rocks, extrusive and intrusive igneous rocks. And we'll show some common examples of extrusive and intrusive igneous rocks here. So again, igneous rocks are formed when magma solidified. They become igneous, they become extrusive igneous or intrusive igneous. When magma solidifies, it crystallizes to form minerals. So as magma cools, different minerals crystallize at different points during the cooling history. So this cooling history might affect its texture. The rock texture It refers to the size of the rock, the shape of the rock, and arrangement of minerals in an igneous rock. So there are many kinds of rock textures in igneous rocks. For example, there are igneous rocks that are glassy. Glassy, the crystal size, um, the crystal present in glassy textures are absent, just like in obsidian. It can also be very finely crystalline, or crystal size is too fine to see with an aided eye. You need to have microscope or magnifying glass. Finely crystalline, up to 1 millimeter. Medium crystalline, 1 to 5 millimeters. Coarsely crystalline, more than 5 millimeters. And porphyry. The crystal size is relatively large crystals in a finely crystalline matrix. So we can see here that there are many igneous rocks on a different position and locations outside and inside a volcano. Examples of rocks formed inside a volcano are plutonic rocks and porphyry, whereas those rocks with glassy textures, most of the time, they form outside or under a volcanic layer. There are two types of igneous rocks to mention: intrusive and extrusive. Intrusive are plutonic rocks. This is when magma solidifies underground. So these are rocks that are formed under the ground. Examples are granite and rhyolite. Extrusive or volcanic rocks. This is when lava cools and solidifies on land or seafloor. Examples are gabbro and basalt. So granite and rhyolite, they form underground, while gabbro and basalt, they form over land. Geologists have different names for igneous rocks based on their minerals and textures. Aside from classifying igneous rocks based on the location when they cool down, there are also categories of igneous rocks based on the mineral content and texture. Most of the time, the basis is the percentage of silica or silicon and oxygen present in an igneous rock. Example, felsic rocks have 66 to 76% silica, and they form in 700 degrees Celsius. Intermediate, 52 to 66% silica, and they form in 900 degrees Celsius temperature. Mafic is 45 to 52. Ultramafic is 38 to 45. As we go down here in this table, the temperature increases. So ultramafic rocks, they form in 1300 degrees Celsius temperature. Magmas are liquids composed of many chemicals, and they affect the composition of rocks in the future when they cool down. Magmas are Magmas have oxygen, silicon, aluminum, iron, magnesium, potassium, sodium, and calcium. And these elements tend to bond and form oxide compounds. Example, silicon and oxygen, they form silica or SiO2. Iron and oxygen, they form iron oxide or FeO or FeT, Fa2O3. And magnesium with oxygen, magnesium oxide. So we mentioned in the previous slide the the kind of rocks called mafic and felsic. Actually, these kinds of rocks, their names are based on the elements present in them. Magnesium and ferric is in mafic rocks, and that's why the first two letters of the element magnesium and the first and last letter of the word ferric, ferric referring to iron. So magnesium plus ferric gold is called mafic. This kind of rock is made of magnesium and iron. Felsic, it's made of feldspar and silica. Feldspar is the most abundant rock type on Earth. Component of feldspar is aluminum, calcium, sodium, and potassium. So we've mentioned in the previous slide that there are kinds of igneous rocks based on the silica component: felsic, intermediate, mafic, and ultramafic. The most common igneous rocks are in felsic and intermediate and mafic. Obsidian, granite, and rhyolite are felsic. Intermediate igneous rocks are andesite and diorite, mafic, basalt and gabbro, and ultramafic, peridotite. So there are, if you're reading the book, our reference book, there are terms that you might encounter when reading about igneous rocks. Example, the rocks mica, amphibole, and pyroxene. These are rock-forming silicates. These are silicate minerals that may form rock in the future. Quarks, these are minerals that have ample amount of silica or silicon dioxide. Plagioclase is aluminum mafic, and biotite is a kind of black mica. In this slide, I'm showing you the examples of igneous rocks. Let's go to the second kind of rock, sedimentary rocks. Sedimentary rocks are formed on or near the Earth's surface from the compression of ocean sediments or other processes. And that's why, most of the time, these are rocks that are formed in the oceans and bodies of water. 5% of Earth's crust is sedimentary rocks, but it also covers 74% of the continents. They are formed by erosion, weathering, either chemical or physical weathering, precipitation, and dissolution of existing rocks. So these are examples of sedimentary rocks. Sedimentary rocks can be classified into many categories. Example, clastic sedimentary rocks. These are composed of particles of weathered rocks, such as sand grains and pebbles, which have been transported, deposited, and lithified. Example is conglomerate, or in the local language, this is our gravel. 85% of all sedimentary rocks are clastic sedimentary rocks. There are also organic sedimentary rocks. These are consist of lithified. When you hear the word lithified, they are formed they became rocks, and they are the remains of plants or animals. Example is coal. There are also chemical sedimentary rocks. These are formed by direct precipitation of minerals from solution. So in short, they are products of chemical reaction. Example, rock salt. And lastly, bioclastic. Bioclastic sedimentary rocks are composed of broken shell fragments. These are the shells of the mollusk and similar remains of living organisms. This graph shows us the proportion of sedimentary rocks on Earth. So most of the sedimentary rocks here on Earth are mudstone and siltstone. That is 70%. And sandstone comes next, 15%. Limestone is 10%. And other kinds of sedimentary rocks are 5%. So we've mentioned the four common types of sedimentary rocks: clastic, bioclastic, organic, and chemical. In the table here at right, we can find uh, examples of the said types of rocks. Clastic, conglomerate, sandstone, siltstone, mudstone. Bioclastic, limestone, dolomite, coquina, chalk. Organic, shirt coal, and chemical, evaporite, and some dolomite. So for clastic sedimentary rocks, they are made of many different kinds of um, rocks lithified through compaction and weathering. So, for example, there are many particles in plastic sedimentary rocks, and they are named according to their size. Boulder, if it's Uh, if it's larger than 256 in millimeters, cobble, pebble, granule, sand, silt, or clay. Well, in our local language, are all called balas. But there are many kinds of balas. The balas or yung lupa can be named in different names depending on their size. They can be called boulder, cobble, pebble, granule, sand, silt, or clay. So again, they're also made from living things in the past. Coal and bioclastic limestone are made from what the of fossil remains or living things in the past. In particular, coal is a kind of special sedimentary rocks, organic sedimentary rock, because they're formed millions of years ago from plant remains. So coal is formed through four stages. First, peat is this combination of plant matter. Then through time, it becomes brownish in color. So the name of that brownish coal is lignite. And through pressure, heat, and time, they become bituminous. And the present day coal is called anthracite. So 300 million years ago, before dinosaurs even existed, many giant plants died in swamps. Then 100 million years ago, these plants were buried under water and dirt. So time and pressure, heat, they became coal. So dead plants became coal. So coal are literally coal. Coal is a kind of rocks. It's a kind of rock that is literally made from dead plants. There are also sedimentary rocks that can be considered as limestone. They are called limestone because they are made of calcium carbonate or maybe magnesium carbonate. Common forms of limestone include the following: pyroclastic limestone. We have oolite, as you can see here in this slide. Most of these are found underwater. So when sedimentary rocks are formed, they form bedding or layering. The most obvious and common sedimentary structure is bedding or layering. If you are in the field and you can find these structures, just like layers and layers of soil, these are features of sedimentary rocks. Then, if you cannot find, if you can find this the structure in the previous slide, sometimes we can find underground and the ancient ripple marks preserved in many different kinds of sedimentary rocks. Example, we can find it here. The ripple marks, these are small semi-parallel ridges and troughs formed mostly in sand by wind, water currents, or waves. They are preserved when the sediment is lithified. We go to the last kind of rock, metamorphic rocks. These are rocks that arise from transformation of existing rock to new types of rock in a process called metamorphism. The word metamorphic means change. So metamorphism is a process that changes in mineral composition or texture that occur in solid rocks as a result of increasing pressure or temperature. There are two types of metamorphism: contact and regional metamorphism. Contact metamorphism occurs when rocks come in contact with a heat source, usually a magma body. So in the process, rocks are literally cooked, but they don't melt. Texture changes but the composition remains. Marble is the best example when limestone, a sedimentary rock, is heated. So limestone, for example, when it is cooked but doesn't melt, it becomes marble. In picture above, this is a rock called marble. This is when limestone is heated. Below is quartzite. Quartzite is a metamorphic rock when sandstone is heated. So when sedimentary rocks are heated, they can become metamorphic rocks. Another example of metamorphism is regional metamorphism. This occurs when rocks undergo increased temperatures and pressures, typically associated with the plate tectonic processes that form mountains. So when we say regional, um, this involves wide area or large areas. They are formed in deeper layers of crust. The rocks are formed in deeper layer of crust. They're formed with additional pressure from rock layers above and below. So the sources of pressure are above, rock layers from above and rock layers from below. Figure at right shows foliation. Foliation is a kind of geometric orientation that generates an alignment of minerals into sheets. So when you hear the word foliation, the the metamorphic rocks are arranged into sheets because of the pressure above and below. Or this may result into randomly oriented minerals or parallel sheets of minerals. Example of foliated rocks are slate, phyllite and schist above, and granite and gneiss. So again, metamorphic rocks. These are rocks formed from igneous or formed from sedimentary. Example, marble is a kind of metamorphic rock formed when limestone are cooked. Quartzite is a kind of metamorphic rock when sandstone, a kind of sedimentary rock, is also cooked. Gneiss is a metamorphic rock when an igneous rock called granite is cooked but didn't melt. Metamorphic rocks can be graded according to the temperatures when they are formed. Low-grade metamorphic rocks form less than 10 kilometers deep within the ground, and they form 300 to 400 Celsius in temperature. Medium grade 400 degrees to 600 degrees, and high grade 600 to 800 degrees, or sometimes shallow layer but near magma. Remember that metamorphic rocks are cook rocks. They are rocks na naluto, but then they didn't melt. They just underwent changes in texture and shape. So we can see here, when in an increasing range of temperature, the grades of rocks also increases, from shale to slate to schist and gneiss. So these are examples of metamorphic rocks. For our next meeting, you have to create a Venn diagram for the three classes of rocks. Submit next meeting. Thank you.